Hello friends, we have been seeing about the basics of normal distribution theory in our last session. In this session, we will see how these normal distribution charts can be brought alive using this app or a tool called by the name Geogebra. We normally go for the Geogebra Classic version. Go to your browser and just type Geogebra Classic. This is going to be a mathematical calculating tool. You can draw graph, you can fix areas, you can visualize it in three-dimensional or multi-dimensional view. There are going to be so much of things to be explored or using this app. Come on, we will see how normal distribution can be brought alive using this Geogebra Classic tool. First, after writing your Geogebra Classic, just go on and click on it. You will have something like this, a screen appear too. So this is going to be the basic tool where this is going to be a plus where you go on for your input of the function. Now we are going to go for the different types over here. You can go for graphing, geometry, 3D graphics, calculations, spreadsheet data can be plotted over here and so on. So what we require is going to be probability. So click on probability. Yes, this is the normal curve or your bell-shaped curve. When you are going to have a look at it, you can see that the curve is going to be fixed for mu equal to 0 and sigma equal to 1. So now this curve is going to be your standard normal curve, which means the center line is going to be the point z equal to 0. At the bottom, you can find the normal curve, the value of mu, the value of sigma. Now if you want to find it for some other mu and sigma, you can change the data and the value will be represented in the curve as such. Now this going to be the region where we will have to shade it for. So now the graph has been plotted for probability of -1 less than x less than 1. So the area is going to be found between -1 to +1. We are finding this area over here, -1 to +1. The blue color represents the area between -1 to +1. And what is going to be the total probability that any value will lie over here? It is going to be 0.6827. Say suppose we want the probability of the value between 0 to 1. Okay, so what is this now? From the center, I am going to measure 1 unit, and what is going to be the probability that the value lies between 0 to 1. So now this is given as the value of the probability is 0.3413. If I am going to change this as 2, so what will happen? Now you move on furthermore. You will have to always keep in mind the table which we will be using will be calculating the data only from the center line. What is this center line? This is the point z equal to 0. So from z equal to 0 to z equal to 2. So from probability of 0 to 2. But here since the variable is going to be that of x, it is a general representation of x. But when we do problems, we have transformed the variable x to z. So we will be making use of z. So this is going to be the portion for 0 less than x less than 2. Okay. So now I want it between 0 to -2. So what will happen? Let me change it as -2. So if I am going to plot, so this will be nothing but -2 to, this is going to be your value of 0. So -2 to 0. What will happen? This is going to be the portion to your left. You can see that the answer from -2 to 0, the probability is 0.4772. Make a note of it. From -2 to 0, the probability is 0.4772. Now if I am going to change it from 0 to 2, so we will see what is going to be the value from 0 to 2. What is the answer? The same 0.4772. Why it is this happening? This is happening because we know that the line x equal to mu now changed as z equal to 0 acts as an symmetric line, and both to the left as well as to the right the areas are going to be the same. So whether it is from -2 to 0 or from 0 to 2, the total area is always going to be the same, and this is going to be 0.4772. Now if I want to go for a value beyond a region, okay, so this is going to be from x going to be greater than or equal to, say suppose I want the value for -1. So how to get over here? Okay, so it is going to be, or say it is going to be +1. Okay, so x is greater than or equal to 1. So what is going to be x greater than or equal to 1? So from 1 to infinity, how much is my area? So what is the area over here, or the probability of evaluating between x greater than or equal to 1? 0.1587. Now how to estimate this data? From the center only we know the values are being calculated. So how to get a value beyond the data? We know that half the data is going to be 0.5. The total area from -infinity to +infinity is going to be equal to 1. So half the area of the bill is 0.5. So when you want the data beyond a point, okay, so what you will have to go for greater than values, you will have to subtract it from 0.5. So the total area is 0.5. From the total area 0.5, you subtract your 0 to 1. So you will be getting this required portion. Okay, so say suppose I want it to be the left hand side. So what happens over here? X less than or equal to 1. So when x is less than or equal to 1, what happens? You can see the value is going to be 0.8413, because 0 to 5, what is the area? It is going to be equal to 0.5, and from 0 to 1 the remaining area is going to be 0.0413. So that also gets added up, 3413. So that also get added up with your 0.5, and total value now becomes equal to 0.8413. Okay, so when we want the value to be equal to greater than or equal to -1, say. So what will happen now? This is for -1. So in the same way, this -1 is the same as when we go to the right hand side. Over here, it is going to be equal to that of +1. So this is going to be the equivalent area. So when you want for estimation of a line beyond, then go for half area, which is 0.5, and subtract the remaining quantity from it. Now let us say suppose we want it between, say, -1.23 to the left, and to the right I want it to 0.45. Okay, so this is going to be from one half the left and other half to the right. So in which case what we will do, we will split this into two parts. From -1.23 to 0 will be my first area, and from 0 to this 0.45 will be my second area. I can add both these data so that I will be getting the portion between -1.23 to 0.45. Okay, so this is going to be the answer, 0.5643. Now by changing the values over here, you can get directly the area that lies between any point over here. This is just for your understanding purpose or visualizing how the plots will look like. But for our examination, we will be provided with the normal distribution table. So we will be using the table, and whatever the computer displays here as the probability 0.58, 0.47 and so on, we will be making use of the table to acquire the data. So you can explore how the data will look like using this Geogebra calculating tool. So I hope you can find maths learning is going to be much fun when you are going to visualize things. So try your hands, change your data, find what is the required region, find what is the probability, and explore much more on it. The videos or the pictures which you generate can also be downloaded over here as the required format, PNG or JPG, whatever be it. And when you are using it for your projects, then you can just copy paste these data and then explain or explore much more on it. So I hope that this video was just like an eye-opener for people who don't know about this Geogebra tool. There are going to be many more things which you can explore on this Geogebra tool. It is called as a graphing calculator. There are various graphing calculator, and this is going to be one which is going to be more compatible, available for your mobile apps also, as well as for your desktops also. So try exploring the data. Have a happy time, happy learning of maths. Thank you.